Welcome to video 6 of the 2015 Calculus exam breakdown. Okay, for a function y equals negative ax squared plus bx plus c, a, b and c are positive numbers and b equals to a. Okay, so we've got two equations here. On the grid below, okay, whoops, sorry about that. Sketch the gradient function. Show the value of all intercepts. Okay, so if that's the case, we need to actually write on the intercepts what the values are. The y dashed intercept, so the gradient function, should be given in terms of b. Okay, so they want it in terms of b, so that means we need to eradicate all a's. Gradient function, they want us to differentiate, so let's have a look here what happens when we substitute one into the other. Let's differentiate first and see what happens. So dy dx, or since they want to call it y dashed equals y dashed of x is going to equal negative 2ax plus b. The c goes away, so we don't need to worry about the c. We want it in terms of b, so we don't want a. So if we rearrange this, so a is equal to half of b, basically. So if we substitute that into our equation, that gives us negative 2 times b over 2 x plus b. The 2's cancel out. Negative bx plus b. Oh, that's nice and convenient, isn't it? Okay. So this is the equation of our graph. The y-intercept, y-intercept, is going to be this one over here. Because when x is equal to 0, this cancels all of this out and leaves us with just b. X-intercept is a bit convoluted. X-intercept. So when the y dash is equal to 0, you have bx plus b. X is going to equal to 1. So we can say that this is 1b, okay? See, it's a negative linear equation. So we could say, we could have b all the way down here and 1 here, or we can just use lots of space up and say that b is up here, 1b, this is 2b, this is 1, this is negative 1, and this is 2. Our intercepts come through here and here. With something straight. Grab a ruler and rule right through our points. Okay, so you can maximize your space, and it makes the graph nice and long like this, nice and big, or you can squash everything into a small bit and all that does is it shifts your line from here all the way into here. Personally, I would do it this way just because it makes writing your intercept so much easier. And then I would probably, let's see, the axes are already labelled like that. My scale is on my axes. Negative b, negative 2b down here. I would probably write the equation right next to it. So it gives me y dashed of x is equal to, what was it? Negative bx. Negative bx plus b. There, done. Next. I do have to admit that that last question was a little bit mean because it used a lot of algebra, but for an excellence question, I reckon that's pretty fair. Okay. Y is the value of x, so this must be the last question, the last part of the question 3 and the last question of the exam. Y is the value of x after 3 has been subtracted and then the answer doubled. Okay, so they want us to create an equation. Okay, so they've already given us our variables, which is y and x. They've even given them labels for us. So y is the value of x after all of this. Okay, so y equals x after 3 has been subtracted. X has been subtracted. So 3 has been subtracted from x. And then the answer doubled. Okay, so that has to be that first, then multiply by 2. And x is between negative 0.5, negative a half, and 3. Okay. Find the minimum and maximum values of the product, x squared, y. Okay. So if we call that P for product equals x squared y, we've got two equations. Let's get rid of our y. So this is a lot like simultaneous equations. This is simultaneous equations. What am I saying? So that's my first equation. That's equation 2. Sub 1 into 2. Sub equation 1 into 2. Which gives me P is equal to x squared times 2x minus 3. Let's expand that out a bit, shall we? So that gives us 2x times x squared gives me that. 2 times negative 3 is negative 6 times that should be negative 6x squared. Okay? Let me write that a little clearer. There you go. So 2x cubed minus 6x squared. That's now P of x. We want to maximize or minimize. So let's differentiate. It's keywords. So differentiate. So P dashed of x is equal to 6x squared minus 12x. So it's a positive cubic. Yep. At maximum and minimum points, the gradient is always 0. And this is the gradient here. So 6x squared minus 12x. So, this is a quadratic. So, our A value is 6, our B value is negative 12, and our C value is 0. Or you can just simplify it out to give us x squared minus 2x. Like this. And then you can simplify it from there. So we would get our x values at 0 and positive 2. So it's a positive cubic. So it's something like this. So that must mean our local max is here and our local minimum is here. And they want to know the product. So this is the original question then that we need. The original equation. One of them. So P of 0 is going to give us, we need to find the y value, don't we? Let's try that again. So y when x is equal to 0 is equal to 2 times 0 minus 3. 2 times bracket 0 minus 3, which gives us negative 6. The y value when x is equal to 2, negative 1, negative 2. Okay. So P at this point is going to give us, well, it's going to be 0, because anything times 0 is going to be 0. Anything times 0 is going to be 0. So if we've got our original equation is x squared minus y, square of 0 is 0, 0 times anything. 0. So P, when we've got 2 squared times negative 2, is going to give us negative 8. Okay. So the maximum value and our minimum value. Cool. And we're done. Thanks for watching. Catch you next time.